I'm Shraddha from CSE Department Section F. My AAT topic is the virtual reality modeling language. To understand this virtual reality modeling language, this virtual reality modeling language is a standard file format for representing 3D interactive graphics in a browser or a web page. It allows for the creation of virtual worlds that can be navigated and interacted with in real time. Virtual reality modeling files can be embedded into web pages, enabling users to experience 3D models directly into their browsers. It provides a reality graphics which provides user to experience 3D models directly into their browsers. History of virtual reality modeling language. Virtual reality modeling language was first developed in the early 90s in order to bring 3D graphics to the World Wide Web and to be available to everyone. It first the first official specification virtual reality modeling language 1.0 was released in the year 1994, and the second version of this virtual reality modeling language 2.0 was released in the year 1997. Over the years, virtual reality modeling language has evolved and got itself better in order to have user to have a good experience with the virtual reality modeling. And this virtual reality modeling language has evolved and influenced other standards such as X3D, which continues its legacy. Basic syntax of virtual reality modeling language. Virtual reality modeling language is a text-based and uses .wrl as its syntax to save a virtual reality modeling language file. Virtual reality modeling language uses a specific syntax to define 3D objects and scenes. Each virtual reality modeling language files begins with the declaration of virtual reality modeling language version, followed by nodes that define shapes and properties. Nodes can include geometric shapes, transform nodes, and various attributes to define appearance and behavior. Virtual reality modeling language nodes. Nodes are the fundamental building blocks of virtual reality modeling language files, representing objects, lights, and cameras. Each node can have fields that specify values for properties such as position, color, and scale. Common node types are shape, materials, and transform, each serving specific its scene. Geometric shapes in virtual reality modeling language. Virtual reality modeling language supports a variety of geometric shapes including spheres, boxes, and cylinders. These shapes can be customized using various fields to define the dimensions and appearance. Complex models can be created by combining multiple geometric nodes and transformations. These nodes are used in virtual reality modeling language. This virtual reality modeling language gives access to use various geometric shapes, which include sphere, boxes, cubes, cuboid, cylinder, etc. This virtual reality modeling language syntax is similar to JSON and XML. This but this virtual reality modeling language uses nodes and attributes. This virtual reality modeling language works on different operating systems with compatible viewers. Textures and materials. Textures and materials enhance the visual appeal of 3D objects in virtual reality modeling language environments. The material node allows user to define properties such as color and transparencies, as we have previously discussed about color and position. Each node of virtual reality modeling language nodes, each node can have specific values for properties such as position, color, and scale. This nodes can also have shape, material, transform, and it each serving specific purposes in each scene. Animation and virtual reality modeling language. Virtual reality modeling language supports basic animation capabilities through the use of interpolation and time events. Users can create animations by defining keyframes and specifying transformations between them. Animations can enhance interactivity and provide a dynamic experience within virtual worlds. These virtual reality modeling language allows user interactions like movements and object manipulation. This virtual reality modeling language is mainly used in animations as it can create 3D models for animations. User interaction. Virtual reality modeling language allows user interaction through events and scripting capabilities. Users can manipulate objects, navigate through scenes, and trigger animations using mouse, click, or keyboard input. The interactivity helps make virtual environments engaging and immersive for the users. These virtual reality modeling language successor, this is replaced by X3D, which offers improved features of XML based encoding. Virtual reality modeling language and the web. One of the key advantages of virtual reality modeling language is its ability to be integrated into web pages. Basically, this virtual reality modeling language is mostly used in web pages, which provides user and friendly way and a reality way in getting the experience. Browsers equipped with virtual reality modeling language plugins enable users to view and interact with 3D content seamlessly. This accessibility has contributed to the popularity of virtual reality modeling language in early web based on 3D applications. Virtual reality modeling language browsers and plugins. This virtual reality modeling language browsers, various virtual reality modeling language browsers and plugins have been developed to render virtual reality modeling language content on different platforms. Popular examples include Cosmo Player is one of the virtual reality modeling languages plugins, Internet Explorer with virtual reality modeling language support, and other standalone viewers. As technology has advanced, support for virtual reality modeling languages in modern browsers has diminished in favor of newer technologies. This virtual reality modeling language is basically an older version, which now is its use is minimized as the technology has new languages, and many of the people prefer to use new languages due to some limitations in virtual reality modeling language. Now let us look at these limitations in virtual reality modeling language. Despite its capabilities, virtual reality has lot of advantages. With as it has lot of advantages, it also comes with many limitations. Few limitations are as shown here, such as performance issues with complex scenes. When there is a complex scene and there is when we use virtual reality modeling language, it basically becomes overcomplicated and we cannot write that language. The lack of widespread support in current web browsers has hindered its usage in contemporary applications. Furthermore, virtual reality modeling language specifications does not allow fully addressed advanced graphical techniques, limiting its potential. So let us now, as X3D has replaced virtual reality modeling language, let us see what are the key differences between virtual reality modeling language and X3D. X3D is a successor to virtual reality modeling language designed to overcome its limitations and incorporate modern 3D graphic features. This X3D was created or generated due to some limitations in virtual reality modeling language. Unlike virtual reality modeling language, X3D supports both XML and binary encoding, improving data interchange and integration. Whereas virtual reality modeling languages only support XML, but it does not support binary encoding. But X3D supports both XML and binary encoding. This improves data interchange and integration. X3D also includes support for advanced rendering techniques, making it suitable for current applications. Nowadays, technology is so advanced and the needs for the people has increased. So X3D provides better usage for the people rather than virtual reality modeling language. What are the current uses of? People still use virtual reality modeling language. It isn't that it's completely ignored, but it is outdated. While virtual reality modeling language is largely considered outdated, it, it laid the groundwork for the later 3D models. It is the beginning of 3D graphics. Uh, X3D was developed on the basis of virtual reality modeling language, and it is a better version of virtual reality modeling language. Even though it is outdated, it laid the groundwork for 3D modeling languages. Some legacy applications and platforms still use virtual reality modeling languages for education and training purposes. Certain niche markets, such as virtual museums, may also continue to use virtual reality modeling languages in specific scenarios. Future use of 3D modeling languages. Modeling languages such as X3D, WebGL, and virtual reality modeling languages are used in 3D modeling. The future is more advanced, and people will prefer to use X3D and WebGL rather than virtual reality modeling language. These technologies offer enhanced performance, better interactivity, and compatibility with modern web standards. As virtual and augmented reality continue to grow, new modeling languages will emerge to meet evolving demands. Conclusion: virtual reality modeling languages played a significant role in early development of 3D graphics. Although um, it has helped us a lot, nowadays people avoid virtual reality modeling languages and use X3D or WebGL instead of virtual reality modeling languages due to its limitations. Understanding virtual reality modeling languages helps appreciate the evolution of 3D modeling and its impact on interactive graphics today. So this is my idea on virtual reality modeling language. Thank you.